Hello, here's a quick problem on finding the acceleration of two objects attached to an Atwood machine. So here are the following formulas we're going to have to use. Newton's second law, Fg equals mg, and of course g is equal to 9.8. Now first thing I'm going to do is I'm going to label my system. So my system is the two masses attached to the string. And we're going to assume this is a massless string. And this is also a frictionless Atwood machine. Now, besides that, the reason why I'm doing that is because if both of these things are my system, that means we only care about external forces. We don't care about internal forces. Since the string is part of my system, actually, that means we actually don't care about tension. So tension is not an external force, so it's not causing the acceleration. So what is causing the acceleration? Well, let's look at the external forces. We have gravity pulling down on the first box. We'll call that Fg1. And then we have gravity pulling down the second box, which we'll call Fg2. So let's also make a point of reference too. As you can guess, either it will go down on the left side or go down on the right side. You know, these two objects are moving together. But let's give it a general direction. Let's say if it goes down on the left side, it'll be negative. And if it goes down on the right side, it'll be positive. So you can probably guess that since the heavier mass is on the left side, the whole system will just move in the negative direction. It will just pull down. But we'll label it the way we did, and let's move on to the actual problem. We've already identified the external forces. It's Fg1 and Fg2. Notice that Fg1 is moving is directed in the negative direction, what we labeled as negative. So we'll say negative Fg1, and then we have to sum the other force, so plus Fg2, over the mass of the system, which we said was both boxes, so it'll be m1 plus m2. Now instead of Fg, we'll use mg, so we get some actual numbers going in. So Fg1, that'll be m1 times g, because that's the mass of m1. And then Fg2 will be m2g. So negative m1g plus m2g over m1 plus m2. Alright, so we can actually factor out a g. So let's go ahead and do that to make this simpler. So g, you have negative m plus m, and m2 over m1 plus m2. And just to make it'll look a bit better, we'll do g times m2 minus m1 over m1 plus m2. Now we're actually given m1 and m2, so we'll actually just plug in the numbers. G is 9.8, and then we have 1.2 is 2.9 over 2.9 plus 1.2. And let me just pop that into the calculator, and that should give you negative 4.06 meters per second squared. So what does the negative indicate? So the negative indicates that the system is going down this way on the left side, and we labeled that as negative, and that should be intuitive because this was the heavier mass, so it should fall along the direction of the heavier mass. All right, so that's the first part. We know the acceleration. So now let's just find the tension. So in order to find the tension, we're actually just gonna relabel our system essentially. So let me get rid of this. All right, so just keep track. This is our acceleration. So we know both objects were accelerating at negative 4.06 meters per second squared. So we're now just going to focus on one of the masses. We'll focus on M1. That'll be our new system. And let's draw a free body diagram. We have gravity pulling it down, Fg1, and then we have the tension of the string, which we'll call F sub t. So again, we have Newton's second law. A is equal to sigma F over m, our system. Now, we actually know the acceleration. As it's falling, its acceleration is negative 4.06 meters per second squared. But before we plug that in, let's actually solve for our tension force. I'll actually relabel this too. We'll say up is positive, down is negative. So let's first identify the forces occurring, which we already did. It's our tension force, F sub t. And then we have our gravitational force, Fg1, plus, and we know that's going in the negative direction, so I'll put negative Fg1 over the mass of the system, which is just m1. So this is Ft minus Fg1 over m1 is equal to A. And we want to find the tension force, so we'll isolate for F of t. So multiply times m1, we have m1 A is equal to Ft minus Fg1. So we'll just add Fg1 to both sides. And we'll have m1A plus Fg1 is equal to F of t. So let me just pop that in the calculator, and that'll be our tension force. That'll be our final answer. Before I use the calculator, I'll actually further simplify. So we have Ft is equal to m1A plus Fg1, but instead of Fg1, we'll put m1G. And I can factor out an m1, and we'll have A plus G. Now let's just plug in our values. m1 is 2.9. A is negative 4.06, and let me explain that real briefly. We know the magnitude is 4.06, and just be careful. Take note that we did use a different reference from a previous problem. So up is positive and down is negative. So it just so happens to be that it's still negative 4.06 just because how we referenced it. If we used M2, for example, it would actually be a positive 4.6 because we would say up is positive and down is negative. So when you're using acceleration, remember it is a vector. Just know which direction it's going in. And we have plus 9.8. So let's just plug this into our calculator and let's see what we get. So I have 16.65 newtons. And that's our final answer. So in order to get tension, I did use M1 as my system, but you can also use M2 and you should get the same answer. And that is all for today. Thanks for watching.